Hi, everybody. Hi, Caitlin and Asipe. Welcome back, Selena and Rosario and Karabo and Atankosi and Zwelichle. Welcome back. This is our fourth session, Q&A. Nice to see some of you back, some familiar faces. If there's anyone joining us on the live stream, welcome to you as well. You can start having a look at this first question that we've got. Mpo submitted this question. So have a look and start thinking about how we're going to solve this equation. And also, while we just give it a few more minutes for everyone to arrive, please put in the chat if your exam is coming up this week. I know some of you have already written your prelims, but please tell us if you are still writing this week, maybe tomorrow or Friday. Thanks for joining us, Benedict. Welcome. Is there anyone writing this week still? Put it in the chat for us. Hi, Zulichle. Put it in the chat so that we can wish you good luck and send you good thoughts as you write your exam. Hi, Ayumide. Welcome, everybody. Is there no one writing this week still? No one writing on Thursday or Friday? Did anyone write today or yesterday? Because we had our session on Monday and some people wrote and they said it was tough. So I'm wondering, has anyone written in the meantime or still going to write this week? Let us know. Just put it in the chat if you are one of those people. And in about 2 minutes, we'll start looking at this question 1.1.4 that was submitted to us by Mpo. Mpo isn't here yet, I don't think. So we'll hope she arrives.
I'm here.
Are you here, Mpo?
Yes.
What is your name? Under what name are you?
I'm Karabu. Rabu. Just Mpo is my other name.
Okay, great, Karaba. Well, we're going to do your 2 questions tonight.
Okay, thank you.
Sure. Thanks for submitting them.
No problem.
And Rechamuditswe, welcome. And Timothy is back as well. And Tepo is back. Okay, so let's get going. Mpo, can you maybe tell me where you got these 2 questions from? Was it from a past paper? Was it a national paper? Was it your school's paper? If you could just let me know. It's always interesting to know where the questions come from.
I got it from the prelim from last year. Yeah, last year's prelim paper.
From your school?
On the app, on the thingy, what's it called? Mobile application, I think.
Okay. All right, great. Right, so what we've got here is an exponential equation and some basic strategies for solving an exponential equation is to get everything as prime bases. So if we look at the 2's and the 17 divided by 2, so that's already prime bases, so we don't need to worry about that step. The next thing is to try and get everything the same base. So once you've put everything as prime number bases, the next thing is to try and get them all as the same prime number. So be it a 2, a 3, or a 5, or whatever. Now, this question is quite interesting, and I haven't seen a question like this in a while, because you actually it's quite a the way you're going to solve it is something that's maybe not that familiar to everyone. So let's see how we go. And I'm going to start by just breaking up the 2 to the power of 2 minus x into 2 to the power of 2 times 2 to the power of minus x. And let's put that, I'm going to leave the 17 over 2 for now. Let's see what happens. You can maybe multiply through by the 2 as well to get rid of the fraction. That's another plan that you can make. I'm just going to leave it for now and just try and work on the left-hand side and see if you can, if we can simplify that. Timothy, yes, you are allowed to invite a friend, most certainly. We just need that friend, we need to get their details. Coco, can you maybe just chat to Timothy directly, maybe on DM, and just see who his friend is and how we can get the friend.
Sure. I believe they will be sending WhatsApp links that you can send to the friend that you want to join. But I think that is going to be the end of this week, and then your friend will be able to join us from next week.
Yeah.
Okay.
Timothy, so I don't think he can join right now, but he's more than welcome to join the live stream on the website. So Coco, can you maybe just send
yeah, let me put it in the chat now quickly.
Yeah, if you can just send him the link to the live stream. So he won't be in our Zoom class, but he will be able, he can most certainly follow on the live stream.
Yeah.
And then we'll get a link to you via WhatsApp for the next session. I hope that
share that with everyone. If you want to just copy and paste it and give it to anyone, they can watch along with us on the live stream.
Yeah, that's great. Okay, so back to our sum here. So the other thing is we don't really like working with negative exponents, so we try and make them positive as far as possible. So I'm going to take that 2 to the power of minus x and make it 1 over 2 to the x. Okay, so prime numbers, same bases, and negative exponents, try and make them positive by putting them in the fraction below the line, or if they're below the line, put them above the line to make them positive. So this takes you right back to grade 9 exponents. Okay, now not much more I can do here. I can maybe go, okay, let's make it slightly simpler and make it 2 squared over 2 to the x is equal to 17 over 2. So what I'm actually going to do now is I'm going to say it's going to be easier for me if I replace this exponent just with a single variable. So I'm going to use K method substitution. And I'm going to say let 2 to the x equal k. Now it's known as K method substitution. Why it is the preferences for k, I can definitely not tell you, but you can use another variable, just not an x, because you're trying to solve for x. So just take that whole exponent, that whole thing that you're trying to solve for, and make it another variable. And then it's going to be slightly easier for us to do. So, and I'm also going to change the 2 squared now to a 4 over k, and that is 17 over 2. Now that's looking a little bit easier to do, right? So once we get to the very end and we solve for k, and we have a value for k, we're going to go back and solve for 2 to the x. Now, this is quite, I couldn't see the mark allocation here. There's no mark allocation that I could see, but this will be quite a lot of marks, probably 6 or 7 marks if you do this. So now we've got a fractional equation, and we are going to multiply with the LCD. And the LCD in this case is 2k. So I'm going to multiply by 2k right through. So each term is going to get multiplied by 2k times by 2k. With the k, 4 over k gets times by 2k, and 17 over 2 gets times by 2k. Please stop at any time if I need to explain why I'm doing something. Just put your hand up or unmute yourself. We're not that many in the class, so we can just have a conversation. It's really not a problem for you to just say if you don't understand, because I guarantee you someone else might have the same question in the back of their mind brewing. Okay, so k times 2k is going to give me 2k squared. Here I've got the k is going to cancel with that one, so that's going to give me 8. And here the 2's will cancel, and I'm going to have 17k. Now this is starting to look like a trinomial, right? Because I've got a k squared, I've got a constant, and I've got the 17k. So I'm going to bring the 17k over to the other side and subtract it. And make that equal to 0. Okay, so now we have to factorize this trinomial. And I need the factors of 2 and the factors of 8 to cross multiply and give me 17. The signs must be the same because I've got a plus 8. So I can already see that both my signs in the brackets are going to be negative and negative. And the only factors that I can think are going to work is going to be 2 and 1 and 1 and 8. Because 2 times 8 gives me 16, 1 and 1 gives me 1. If I add that together, that gives me 17, which is the magic number in the middle that you need to get. So my bracket will be 2k minus 1, k minus 8. And that is equal to 0. Now I'm going to solve my 2 brackets. I get 2k minus 1 equals 0, or k minus 8 equals 0. And 2k, I'm going to solve this one first. 2k is 1, so k is a half. Or k is 8. But now we're not solving for k, we're solving for 2 to the x. So I'm going to go back and say, but originally I said k is actually 2 to the x. So 2 to the x is equal to a half, or 2 to the x is equal to 8. And now we can go, okay, so this is 2 to the x. I can make a half 2 to the minus 1, so x is minus 1. And on this side, 2 to the x is 8 is 2 to the power of 3. Remember, when the bases are the same, you can drop the exponent. When the bases are the same, you can put drop the bases and put the exponents equal. So x is equal to 3. Oh, was it only 5 marks? That's a lot of work for 5 marks. But nonetheless, there we go. That's my solution to it. There might be other ways to do it. I know my solution is quite long, but yeah, If anyone else has done it and have thought of a different way, please share. Or if you've got your hands on the memo there, please share as well if they've done it in another way. But that's my thinking right there. So yeah, let me know if you have any questions or what you think, how that went. Can I see in the chat just some feedback? How did this go? Thumbs up, thumbs down. How do you feel about this question? And is there anything I need to explain again? Got a thumbs on. Atankosi, nice, great. Atankosi says it went great. So exponential equations, that one you're going to ace in the exam, Atankosi. So Lichle also saying thumbs up, all good. Tepo's giving us a thumbs up as well. Timothy saying thumbs up, all good. And Isaiah is also saying good. Okay, excellent. Great, guys. Because yeah, we got to be ready for anything. They might ask an exponential equation. So yeah, there you go. All right, so then we can move on, I think, if everyone is feeling good about that one. Where's your other one? Let me just find it on the screen. There we go. Determine the solution. So we're jumping from paper 1, solving exponential equations, to paper 2, solving a trig equation, a general solution question. Okay. And if you were here on Monday, you'll remember I said that there are some notes that I want to actually give you about trig equations and the different types of trig equations. Because there are so many different equations for trig, and you've got to actually know how to work with all of them. So, so when you've got a trig equation, you can have two types: a general solution, like our one is here, and a specific solution. A specific solution is when they give you an interval and they say, just give the values of x between, for instance, negative 180 degrees and 90 degrees. So then you're going to give very specific solutions for x. So that can be the two types, the two main types. Then you get really easy sort of grade 10 level trig equations where you just use your calculator to solve. Then there are those that you have to factorize, and under those you can, and what comes up a lot is trig trinomials. And in fact, the one we're going to do tonight is a trig trinomial. So trig trinomials come up, or just taking out a common factor. Okay, so you can have a trig trinomial, or if the examiner is feeling merciful, they'll just give you a common factor. My money is always on trig trinomials because it really combines all your algebra knowledge with your trig knowledge, and you'll see now your identities of double angles and compound angles as well. Now there are 3 tricks that you need to know, 3 weird ones, three ones that you don't solve in the normal way. So normally you'll just find a reference angle and then do your quadrants and then find your general solution. But there are 3 of them that don't quite work out that way. And the one is where you have sine of A equals sine of B. And I think I spoke a bit about it briefly on Monday, and I said, if you have the same trig ratio, different angle, then you don't do a reference angle, you go straight to your quadrant and you put the 2 angles equal to each other. If you have sine and cos, angles are the same, then you make a tan. And that's what we did on Monday. We had an equation where we had to make a tan. And that's just something that I call a tan trick, or make tan. And the other type of equation that you can get is where you have sine A as cos B. So sine and cos, so check how this one is different to this one. So sine A, cos A, angles are the same. And here it's sine A, cos B, so angles are different. And then you have to do the 90-degree rule, where you change the cos and sine, and then you're actually back here. Then you follow that path. Okay, so I'll leave that up for a seckie for you to take down if you're finding that useful. And maybe what I can do is I can put the question up as well. Let me see. Can we all see it? Yeah. So you can see our question that we are going to do, the general solution of 4 plus 7 cos theta plus cos 2 theta. So I'm going to give you 5 minutes to get started on this question and work quietly for about 5 minutes, and then we'll all talk about it together. And I'll leave up my little scribbles about trig equations if you do find it useful and you want to take it down. So at 25 past, we'll all come back together and have a look at this general solution question. In the meantime, while people are working, feel free to ask me a question if you want. Or Coco, you can ask Coco as well. No problem, Jaden. You can get stuck in with our general solution question that's up on the board.
No, we don't have a lesson tomorrow. And you can leave early if you need to. It's okay. The lessons will be up on YouTube, so you'll be able to see everything that you missed. Okay, we only have lessons on Mondays and Wednesdays. Okay.
Bye, Nao. See you next week. Next week, Monday. Right, so I wonder, can I see how this went? If you've started, if you haven't finished yet, it's okay. Can I just see how people are doing so far? Just give a thumbs up if it's okay, thumbs down if you don't know or not quite sure what to do. Please, Matrix, can I just have a thumbs up or a thumbs down? If you are happy with this question, give me a thumbs down up. If you are not happy, give me a thumbs down, please. Just want to see how everyone is finding it and where we are with general solution. Okay. Okay, not so great. Okay, right. Okay, so quite a few thumbs down. Mpu says thumbs up. Okay. Where do we start? Okay. Now let's, if you want to just maybe refer to my notes here, because this is definitely doesn't fall within the easy category. And it doesn't fall in the realm of any of the tricks, actually. It's, if you look at the sort of skeleton I made for the 3 different tricks, those don't really apply here. I think we're going to have to solve this using factorizing. How do I know that? Okay, well, already we can see we've got a 4 here, and then this 7 cos theta, and then this cos 2 theta. Now, there's no way we can try, maybe go 7, take the 4 over to the other side, make that -4, but then we can't take out a cos as a common factor. But what can we do with this, with cos 2 theta? This is your matric work. What can we do with it? Does anyone have any ideas? We spoke about it on Monday as well. What can we do with the cos 2 theta?
We can expand it, ma'am, since it is a double angle identity.
Perfect. That's exactly what we're going to do. Now, if you look at cos 2 theta, there's 3 options for cos 2 theta to expand it using the double angle. How do we know it's a double angle? Because it says 2 times theta. 2 times means doubling it. Okay. So there's cos squared theta minus sine squared theta. That's the one option. I'll write them down here. Cos squared theta minus sine squared theta. That's the one option for cos 2 theta. The other one is 1 minus 2 sine squared theta. And the other one is 2 cos squared theta minus 1. Those are the 3 options for expanding. Again, just a reminder, you don't have to learn these. These are on your formula sheet in the exam, okay? You just have to choose smartly now. So the first one and the second one, if we choose them, we're going to introduce a sign into the equation, and that is just going to make everything harder. So those two I would eliminate. Let's stick to cos. Try and only have one trig ratio in your equation. Don't bring a sign in there, or don't bring a sign in. It's going to make everything, it's going to make it not work actually. But the thing that is going to work is changing it to 2 cos squared theta minus 1. So we go 4 plus 7 cos theta plus 2 cos squared theta minus 1 is equal to 0. Okay, now you should start feeling, oh, this is going somewhere. Let's simplify. Let's add the numbers and make it 7 cos theta plus 2 cos squared theta plus 3 is equal to 0. Now, what do you see? You see a cos squared and a cos and a constant. So this is a trig trinomial. It's a trinomial. It's got a square term. It's got that same term just to the power of 1 plus 3. So it's got the constant as well. And I'm going to put it all together. Cos squared in an order that's familiar. 7 cos theta plus 3. And now we are going to factorize that, just like we would a normal trinomial. Now you can, and I'm actually going to do this for those of you who are struggling to see that it is actually a trinomial. I'm going to, just like I did in the previous question with the K method, I'm going to replace the cos theta with an x. Let's make cos theta equal to x. Then this is 2x squared plus 7x plus 3. Okay, and now that's easier for you to recognize maybe because that is something that you're used to seeing. It's a trinomial. Okay, this is like just something I'm doing to help you see it if you're not sure. It's like it's in the parking bay. Now let's factorize it. So we need the factors of 2 and the factors of 3 to give us 7. So 2 times 1, and I'm going to do 1 times 3 like that. Everything is going to be positive in my brackets. So this is going to be 2 cos theta plus 1 and cos theta plus 3. And we put, now from here on, we solve it like a normal trinomial. Cos theta plus 1 is equal to 0. Cos theta plus 3 is equal to 0. This is going to be cos theta is minus a half. And this is cos theta is equal to minus 3. So this solution is actually not going to work. This is going to be invalid because cos cannot be smaller than -1 or bigger than 1. So cos has to be between -1 and 1. You can put it into your calculator if you want to check cos of -3 and it will give you an error because it doesn't exist. So that one you can eliminate already, but cos theta of -1/2, that you can do. And the steps for doing that is you go onto your calculator and you say, and you find your reference angle. The reference angle you just find by saying shift cos, let me just grab my calculator. Shift cos 0.5, and that is 60 degrees. Now, when you do your reference angle, you don't put -1/2 into your calculator. You just put in, Seppo, be careful. Don't put -1/2 into your calculator. Just put a half because we're looking for the acute angle. We're going to deal with the negative now when we do our quadrants. Because cos is negative in which quadrants? Cos is negative in the second and the third quadrant. So our second quadrant solution, we write it as theta is 180 minus 60 plus k times 360, where k is an integer. And our third quadrant solution, that's where all the angles are defined by 180 plus the reference angle. So it's 180 plus 60 plus k times 360. And you don't have to write it again. As long as you write k as an integer once, that's fine. But you have to write it once at least. So then theta is equal to 240. And sorry, I forgot to simplify this one. This is the 120. You see where your 120 now comes from. Okay, times 360. So that's why you get the 120, which is right. And then the 240 is in the other quadrant. And that's it. That is your general solution. It's the general solution because of this plus k times 360 that we add at the end. Where will our marks be? You will definitely get a mark for, let me make it in purple, for this, for changing cos 2 theta to 2 cos squared theta. And then probably another mark just for setting up your trinomial. And then for factorizing your trinomial. And then for your two solutions, that's another mark. And then for this one here and that one. So that's 6 marks. Easily 6 marks. And I would say as a grade 12 student writing matric, you need to know how to do a question like this or very similar to this, where you have to expand a double angle and then get a trinomial that you have to factorize. If you work through lots of past papers, you'll see that it gets asked quite often. Okay, any questions about that before we move on? Give me a thumbs up in the chat if you think you'll be able to do this one in the exam or something similar to this in the exam. Give me a thumbs up if you think now you'll be able to do it. Timothy, good. Confident. Regmoditwe, confident, good. Karabo, good. Awesome, great, Atankosi. Yeah. And Ayumide also, great, guys. All right. When you go through past papers, hunt for these types of questions, okay? Just work through those past papers and look for them and practice, practice, practice your trig trinomials. Okay. Now, I want to come back to those are the only questions we had submitted tonight. So thanks, Mimpo, again for those. They were great. And I thought for the rest of the time, we can carry on with what we were doing. We were doing 2019, the supplementary paper. And we started this question. And do you see, do you remember here we had the expansion of cos x minus 30, this question 6. And then in the end, we had to make a tan. That was the one where we had cos x, sin x, and then we make tan to solve the equation. And I think I still explained it here. Cos x, sin x, there we go. yeah, that's still from Monday. So I thought let's carry on with that question because it does go into a trig graph. So I am going to put that up. There's some of my scribbles in there already, but I think have a look. We haven't done a trig graph question yet. So again, I'm going to give you 5 minutes to have a look at just read the question and just see if you can, if you understand why I've plotted the points where I've plotted them, and then we'll get going on the questions. Okay, let's have a look at our two graphs here. So you see how the question about the general solution, it's the same graph. It's cos x minus 30 is equal to 2 sine x. And actually what we did already in 6.1 was find the point of intersection. because where the two graphs intersect, that's where the equations are equal. So we already did that work in 6.1. And general solution is often mixed in with your graph for exactly that reason. The graph, the point of intersection, is the same as the general solution, the point where the two equations are equal. So here they've gone and they've said, okay, so here's the graph of cos x minus 30 and g of x 2 sine x. So just by looking at those two equations, it's always good to think, how have these graphs been shifted? And you'll remember on Monday, I said to you when I was making that summary that it's a very good idea to go study your mother functions, the cos x, sine x, tan x, so that when they are shifted, you can kind of figure out what is happening, because you keep relating it back to the mother graphs. Okay. So in this case, we've got the cos graph, and I highlighted that in this orangey color, and it's x minus 30. If we're subtracting from the x, it's always counterintuitive if you're subtracting and adding. So if you're subtracting, you would think, oh, the graph goes left. We are moving it to the left, but actually we are moving it to the right. Okay, so it's always counterintuitive, that move. If it was cos x plus 30, you would think, oh, it's shifting 30 degrees to the right, but it doesn't. It actually moves 30 degrees to the left. So it's always counterintuitive. So maybe if you struggled for a while with these trig graphs, that's one thing to know, that the horizontal shift, the shift left and right, is always opposite to the sine, if that makes sense. Okay, so then g of x is 2 sine x. So first of all, f of x is the cos graph shifted 30 degrees to the right. Then the sine graph, 2 sine x, that is the normal sine graph, and it's been stretched. The amplitude has been changed. So this number in front, that is the amplitude. So we've made the sine wave go higher than what it normally is. It's gone up to 2 and come down, and it dips down to -2. That's the only thing that's changed with the sine graph. Okay. I filled in some points here just because you can kind of anticipate that it's coming, because there's A, B, C, and D, and there will probably be questions about it. So up front, before you even read the questions, just scribble some things down. So I filled in this point here, which is C, and that is going to be at -150 degrees. And I also filled in this point B, it's at -60. And this point here is at 30, point D is at 30, A is at 120. And yeah, so the turning points and the intercepts for the sine graph hasn't shifted, but the turning, all the critical points for the cos graph has shifted because of moving at 30 degrees to the right. Okay, so let's see, what is our first question? It says, write down the coordinates of A, and that's 120 and 0. Why is it 120 and 0? Because the normal cos graph cuts the x-axis at 90 degrees. And if you're moving at 30 degrees to the right, it's going to cut at 120 degrees. So that's how I got that. Just, and you see, it helps to know what your original graph, because then you know, oh, the original graph cuts the x-axis at 90. So if we move it 30 degrees up, it's going to be at 120. And okay, so our next question is the coordinates of C. Now, C and D are both points of intersection. And for that, we can go back to our general solution, because our general solution says that the first point of intersection is going to be at 30 degrees, and then every 180 degrees thereafter. So it will go 180 degrees. You can add 180 degrees, so that'll be 210. But you can also subtract 180 degrees, and that's how you get to 150 for your other point. And that all just comes from your general solution that you did over here, knowing that 180 degrees either way, you will have a point of intersection for the graph. So that point C is negative 150. How do we get, what did I write here, -1? You can put that into your calculator and just put it into this function and say, what is cos of 150? And it will give you -1. So to get the y value, you can just use your calculator. Okay, how are we doing so far? Because this is quite a lot. It's a lot to think about. Any questions so far? Okay, no questions? All right. Then let's have a look. Where is the graph? Both graphs increasing. Pretend you didn't see my answer. Both graphs are increasing. Okay, have a look and see if you can figure out in about a minute, where are both graphs increasing? For which x values are both graphs increasing? That's like the proper mathematical term for it. Determine the values of x for which both graphs are increasing. Increasing means the y values are getting bigger and bigger. So for which x values are the y values getting bigger and bigger? I'm going to let you think about that for about 30 seconds. When you work with these graphs, don't be afraid to get your color pencils out, because it really makes it a lot easier. I can't do them without color pencils. Okay, we want both graphs to be increasing at the same time. And because you're giving a range of values, your answer has to be an inequality. Okay, so a good way to do this, and I hope you guys have tried, because this is also something that they love to ask. But a good way to do it is just to read the graph from left to right. Okay, like a story, like you would read anything. Just read it from left to right, and then look at these sort of critical points. The critical points are the points of intersection and the points where the graphs cut the x-axis, and look what the graphs, how the graphs behave in those with those points. So if I look just at the cos graph, and I just look in this interval here between -180, and I just look here in this bit, between negative 180 and 150. What are the graphs doing? Well, the blue one is definitely coming down. It's dipping down, so it's decreasing. And so is the other one, the cos graph. So sine graph coming down, cos graph coming down. But then at C, the cos graph is actually increasing. And then from negative 150 to 160, if we carry on this way, and we look what the graphs are doing. So for this bit here, actually, I'm going to make it up to this point here, which is negative 90. So if we just read it up to that point, okay. So imagine we're walking, and we're just looking at what our graphs are doing, and we go and we see, okay, up to 150, both are dipping down. Okay, then at 150, cos graph is coming up, so it's increasing, but the sine graph is still decreasing, right? Do you see that? So this one is going up. I'm going to make it positive, so it's increasing, but this one is coming down. But at negative 90, the sine graph is starting to go up. Positive, positive, going to make it positive, positive, positive. And then the cos graph is behaving in the same way. So it keeps doing that. It's going up, 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 up to this point here. Then the cos graph dips down again. The sine graph still keeps going up, but the cos graph comes down. So between this point here, negative 90 and 30, in this interval, they are both for this bit here. We just isolate that. Even if you just take your hands and you cover it and you look at it, then you can see it is going up, it's increasing. And that's why my answer is between negative 90 and 30 degrees. Okay. How's that, everybody? Can you just give me a thumbs up or a thumbs down if you're happy with that and if you understand? I've got 2 thumbs up. Timothy. Atankosi's happy. Caitlin, you've been very quiet tonight. Are you still there? Paul, great. There's Caitlin, yay! Jaden. Awesome, Uzziah and Selena. Good. Okay, I'm not going to tackle the next question tonight. We can have a look at it again on Monday, or you can go look up this paper. It's the June 2019 supplementary exam. And there's also a very nice, I was hoping we'd get time for this 3D question. That's also, but we'll get there. We're almost there. We are working our way through these 2 papers. And then we're doing lots of questions that you guys are submitting. So that's really great. I'm going to leave it there for tonight, guys. I think we've done well. We've done some trick. We've done some general solution. Phew, we've done some exponents. I think it's time to go sleep. Okay, I'm going to hand over to Coco. Thanks, everybody.
Thanks, Marlies. That was a lot, actually, now that I look at it. It was quite a lot, but very helpful. I think you're giving a lot of insight into how to answer questions so you can get all the marks out. So that's pretty awesome. Okay, guys, we don't really have much to say. I just need everybody to pay close attention to this screen right now. Something's going to pop up on your screen, and I just need a very quick answer from all of you guys. So just wait for it. It's exactly 2 questions. You just need to click the answer, and then I will get the answers I'm looking for, and then I'll let you guys go. Okay, it should have popped up on your screen now. So if you guys can just do a quick vote for me. Well, I'm hoping it popped up on your screen because I'm not getting, oh, there we go. There's an answer. Okay. Oh my goodness. Okay.
Oh, this is
yeah. These are pretty shocking. Okay, wow. 11. I'm at 9 answers, so I'm looking for 2 people, 1 more person to answer for me.
that's pretty cool.
I know, we just we're trialing it to see how it works. Okay, I think 1 more person to vote for me. There we go. Thank you guys so much. That is all we needed from you guys today. And thank you for your questions. Thank you for participating. We love
Please
it when you
send
guys
more.
vote.
Please send more questions.
Yeah. Yes. Okay. All right. Thank you very much, guys. That's it from us today. And we will
Good luck
see
with
you
the
guys.
studying.
Yes, we'll see you guys on Monday. Yes, we'll see you on Monday. Bye, everyone.
Bye, guys. See you Monday.
Bye-bye.
Bye then.
Bye.
Bye, guys.
Happy studying. Bye, sweetie Claire.